Awesome. Hello. Thanks very much, everybody. Can you hear me all good?
Yes.
Yep. Perfect. So thank you very much for inviting me to finish off your conference. I hope you've had a fun day. So this talk is called The Lost Art of Software Design. And it's really a talk about my experiences over the last 10 or 15 years. And I'll get into that sort of stuff in a second. So as we all know, and I'm sure we're well aware, the whole Agile thing kicked off in about 2001. And since then, I've noticed many teams have thrown away big design up front, which is definitely a good thing. I'm happy about that. Unfortunately, they've also thrown away things like architectural thinking and documentation and diagramming and modeling. It was one of those baby and the bathwater moments, unfortunately. And it turns out that some of those things are actually quite useful. And there's a great quote I like to use here by a friend of mine, Dave Thomas. And he says this: big design up front is dumb. I agree. Doing no design up front is even dumber. And this quote really epitomizes what I've seen over the past, I don't know, 10, 15 years in the software development industry. So we always like to think in extremes, and neither extreme is a fantastic way to do stuff. And it turns out what's happened in reality is that many teams have gone from doing big design up front to no design up front, but that doesn't mean they're not doing design. So they're just tackling design in a subtly different way. That subtly different way is evolutionary design. So we're doing things iteratively and incrementally. And that's fine, but it's quite hard to do. One of the caveats I want to make right at the start of this talk is I'm referring to technical design, not product design. So by product design, I mean looking at product vision and UI and UX and all that A/B testing and experimentation and kind of getting a feel for your market. Definitely do that stuff. I'm talking about the technical design aspects, by which I mean creating a technical vision, a technical roadmap, understanding and identifying suitable technologies, understanding modularity, and also taking the environmental constraints into account when you're doing that design process. So my goal for this talk, and I want to kind of set my stall out very early so everybody knows where I'm going. I want to explain why some upfront design is useful, because I genuinely think it's a useful thing to do. And I also want to provide some tips on how we can do upfront design better. And my overall approach I'm striving for here, including in my own work, is some design up front, where some will be defined at some point in the future during this talk, with a degree of evolutionary design as well. So we're doing both things. For those of you who don't know me, my name's Simon Brown, and I'm an independent consultant specializing in software architecture. I'm the author of a bunch of books. My last slide is actually a special URL that you can use to download my software architecture books. So don't rush out and buy them in the next half hour. There's a code for some free books at the end. I also do some other stuff I'll talk about in a second. So part of my job pre-COVID, when I could travel, was to fly around the world and run software architecture workshops. And during those software architecture workshops, we used to give people a 2-page set of requirements. And I used to say, right, what I'd like you to do is form groups, go away for about 60 or 90 minutes and do some design. So come up with a software solution to meet that set of requirements. And the output from this exercise was one or more architecture diagrams to describe their solution. And this was done in 2 iterations. Iteration 1, I gave, well, not much help, to be fair. So in iteration 1, I just gave people the requirements. I said, go and get on with things. If you have questions about the requirements, ask me, but I'm not going to help you draw diagrams and do design and that sort of thing. And during iteration 1, we tend to get diagrams like this. So this is just, I don't know, something, it's some boxes with no lines. Another example, so this is boxes and no lines. So this looks like a Microsoft-based solution. We've got some things in the middle. I'm guessing they're components or modules or services, and some database-looking things at the bottom. I'm not sure if they are schemas or databases or all sorts of other stuff. This one here is what people call the functional view, and it's just a list of stuff. This is my all-time favorite. This is the airline route map. So we've got lots of craziness going on. There's a green circle with links to everything else. We've got all sorts of different shapes and colors and mess on the other side, on the left side. This one here is just super generic, and I see this quite a lot. So you'll notice in the middle of the big box, there's a box labeled business logic. It doesn't even tell you what the business domain of this thing is. It's a financial risk calculation system. So this is just architecture 101. It's super generic. This one here is kind of nice, but it doesn't really have any technology choices. So this could be implemented in anything effectively. This one here is like a bunch of C# things floating around a database. This is very easy to mistake this for a microservices architecture, I think, but I don't think it is. I think it's a bunch of C# services or components or modules sitting in an application, but it's not clear. This is what I call the adventure game. There are lots of different paths through this diagram. You start at the top, you go down through the picture. Eventually you die and end up in the trap on the left-hand side. All paths lead to the trap. This one has stormtroopers. You'll notice that there's some little people at the bottom. They're just faceless anonymous clones somehow attacking that reporting service. I don't know who they are, what they're doing, but it's probably not good. And a mess. Now I've got gigabytes and gigabytes and gigabytes of photos from workshops like this. So we do a bunch of stuff during the workshop. And as a part of that stuff, we do something called the perfection game. And the perfection game is quite well known in agile circles. And we get groups to swap their diagrams. So many of the groups think they're going to do a presentation because it's a classroom. And we don't do that. We get groups to swap their diagrams. And we ask them to review the diagrams with a view to listing things they like, listing things they think could improve the diagram. And ultimately, I want the teams to give the diagrams a score between 1 and 10. So we do this for a little bit of time. And it turns out everybody scores the diagrams the same. So this is a real example from a workshop I ran last year, actually in Amsterdam. And it's kind of okay. Got some colors and there's a diagram key and some named boxes. The group that reviewed this said, yeah, this is pretty decent. We'll score it 7 out of 10. Another group scored this diagram a 7 out of 10. And again, it's similar, but slightly different. We've got some color coding. There's a funny little person in the top. It's missing some information, but I suppose it's not bad. This one here shows a layered architecture of some description. There's a front end, which is Angular, and there's a back end that's .NET. Apparently that was also a 7 out of 10. Very suspicious now. This one here was also scored a 7 out of 10. It's kind of more of the same. It's a bit generic. We've got some acronyms and some labeled boxes and lots of unlabeled lines, which is never a good thing. This one here also doesn't really tell you much. This one kind of just tells you what's in the requirements, to be honest. Also scored a 7 out of 10. This one, same deal, 7 out of 10. This one scored a 6. And the thing I find funny about this one is that I think this is probably the most detailed. But I think the detail put people off and they thought, no, that's too complicated, so we're going to downscore it. And it turns out the average score when I do this is like a 7 out of 10. And I've become slightly suspicious of this now. It just seems to happen everywhere I go, all around the world. And it kind of occurred to me that, well, first of all, people don't want to annoy their classmates and the people they work with. And also, a lot of people don't realize that they can do this stuff better. So we go away, we do some more stuff, and then we have a second iteration, which is basically have another 60 or 90 minutes to go redraw your diagrams. And guess what? Surprise, surprise, the diagrams look much, much nicer. So like this, for example, or maybe like this. Now, I've picked a couple of nice looking examples. This was super neat. They're not all this neat, but the concepts are kind of the same here. Now, my workshop is not, so my workshop on the face of it is a diagramming workshop. So it's how to improve your diagramming skills. But actually, in order to get better diagrams, you need to do better design. So there's a bunch of stuff I want to drill into here, because when you ask people to design software, it seems they've forgotten how to do that, hence the lost art of software design. So I'm going to talk about a bunch of topics in turn. And the first is really upfront design. When I go and ask teams what their thoughts are about upfront design, they often respond to me like this. They ask me, are we allowed to do upfront design? which is a bit of a weird thing to ask me. They often say, we're doing the agile thing. Does agile allow us to do upfront design? I'm like, well, yeah, you can do whatever you want to as long as it adds value. So people are honestly asking me this type of question. Same sort of thing. We don't do upfront design because we do extreme programming. Again, there's nothing in extreme programming that says don't do any upfront design. We're agile. This is probably the most common reason that people cite for not doing any degree of upfront design. It's not expected in agile. This is an interesting one. Where does this one come from? Upfront design is not expected in agile. And it turns out when you go read a bunch of the agile literature, you get to see things like this. So in this example from Wikipedia, there is no big design up front, blah, blah, blah. Most of the design activity takes place on the fly and incrementally. So again, it's explicitly saying there's no big upfront design. We tackle it in a different way. Similarly, Martin Fowler wrote a Blicky post a long time ago, and he says, certainly the most aggressive ex-peers are putting more and more energy into avoiding any upfront architectural design. And you'll see this with things like ports and adapters and Engelbaum Martin's clean architecture, where we do lots of decoupling and deferral of decisions. So we'll put something, our file system in place, and if we need to change it later, we'll change it to a database. But we're always choosing the simplest thing that could possibly work. The funny thing about that is, of course, even the simplest possible thing needs to be designed. You need to figure out how to do the simplest possible thing that could work. One of the things I think doesn't help the situation is that on the face of it, when you read the literature, the agile luminaries are saying, don't do upfront design, or don't do big upfront design, sorry. And that's fine, but they're also not encouraging people to do design either. And it's often easy to read into what's not being said. And I think we do that quite a lot in our industry. When I was talking about upfront design, somebody actually said this to me, which is kind of borderline offensive, I guess. He said, I'm guessing you are not a programmer. So I'm talking about doing upfront design and drawing diagrams. He said, well, you're obviously not a programmer because that's not how we do things, which I did take offense to, but I am a programmer. So as part of my role, I also have another company called Structurizer, and this is a whole collection of tooling and a software as a service that I've built myself. So I know how this stuff works, and a lot of the techniques I'm going to talk to you about, I've applied to my own work. Something I think we have to bear in mind here is that the people who put together the Agile Manifesto, they have a lot of experience. We don't have that. So if you look at most teams now, most teams I go and visit around the world, what's the average developer age? Like mid-20s, maybe. Sometimes you see a few older people. I'm certainly in the older people category, of course, but collectively, I don't think we have the same experience that maybe the Agile Manifesto creators had when they put together the manifesto, and that was 20 years ago. So we've got a lot of catching up to do. And that led me to this little moment. So I saw a tweet a while ago from Kent Beck, and he basically said this, I have a couple of weeks free, and so I decided to write a book. And he posted this photo. Now, I don't know why it's upside down, it just is. And he posted this photo, and this photo is basically an outline of the book he wants to write. Now, I thought that was quite interesting, and somebody basically wrote the tweet that I was thinking in my mind. Interesting that you write an outline first. My daughter has discovered that writing with flow, keeping notes, refactoring as she goes, gives her better results. And that's essentially what a lot of the agile people are saying. So don't do this upfront design thing, just get going and refactor, which I thought was kind of interesting. And then Kent replied, I've done circa 20,000 words on software design. To write a book, I need to see a whole, in part just to reduce my anxiety. And I thought that was really interesting. And that's exactly why I advocate some upfront design, because I'm not an expert, maybe like the Agile Manifesto authors were. I want to understand what I'm doing earlier. I want to have some sort of vision and roadmap and direction, because otherwise I'm going to get stuff wrong. So maybe when we take these agile experts out of the software domain, they're in exactly the same situation. The whole agility thing needs a toolbox of techniques and practices. And I think that's what we've stopped teaching to some extent. And you can try this exercise yourself. ask your teammates and colleagues, how do you design software? If somebody gives you some requirements and a blank sheet of paper, what do you do next? And people will pause for a second and think, and then they'll say, well, we use a whiteboard. Great. So what are you using a whiteboard for? Whiteboards don't necessarily give you executable code. So how are you using the whiteboard? And they'll say, well, we draw a bunch of boxes and lines. We do some architecture, we do some upfront design. And then you ask people, what are these boxes and lines? What sort of things do they represent? And they'll say, well, the boxes represent components. And then you have this really long story about, what does a component mean and blah, blah, blah. And eventually people back down and say, well, actually all we're doing is for using experience. And it seems to me that although we can do design, we've forgotten how to articulate the process that we go through when we do our design. And it turns out when you tell people about things like decomposition, and there are different decomposition paradigms and strategies, it surprises them because they've never come across this stuff. You will have seen this paper in every single microservices talk over the past 2 years. It's the Parnas paper about modular programming. And it's a bit hard to read, but it's definitely worth reading, because what Parnas does is basically shows you a set of requirements and then two very different approaches to designing a solution. And those two different approaches have very different characteristics and also very different trade-offs. And again, that's something we want to get more people thinking about. There's never a single silver bullet, perfect right answer. CRC is one of my favorite techniques. It's an old technique. We used to use it in the Rational Unified Process days. And it's a great way to do collaborative design. Now, I don't necessarily advocate that we do collaborative code or class level design, but what I do advocate is that we do collaborative component or service, maybe microservice level design. So there's some great techniques here. Maybe we just need to tweak the abstraction level very slightly. So when I talk about upfront design, I'm not necessarily talking about creating a perfect blueprint, a perfect end state, or any notion of a complete architecture that's never going to be changed. I want to do something else. There's a great blog post about evolutionary design by Josh Kirievsky, and it's subtitled Beginning with the Primitive Whole. And it's the typical, imagine we want to do some iterative development and release things incrementally. We kind of do things in steps. And that's fine. We know this. We've learned this for well over a decade now. The thing very few people talk about is we need to figure out that first step. We need to figure out that initial release. Maybe it's a minimum viable product that we want to use as the basis for everything going forward. How do we engineer that first release so that it is extendable in the ways we think it might be extended in the future? How do we put some sufficient foundations in place so that we can do those increments in the easiest way possible? And that's really what I'm talking about here. I want to put a decent starting point in place. And I want to do that through design. And of course, the Agile Manifesto talks about design. It's just on page 2. You have to click through to the principles. And it says this: continuous attention to technical excellence and good design enhances agility. And the other way to think about this is a good architecture it enables agility. And this kind of makes sense, doesn't it? If you've ever worked on a really horrible code base where everything's a big ball of mud and you change one thing here and all of this other stuff breaks and you don't really know why, that slows you down. It doesn't allow you to make those changes rapidly and deploy releases quickly. On the flip side, if you've ever worked on a solution that's nice and neat and well designed and modular, and changes tend to be isolated to individual smaller units, that makes you go fast. Unfortunately, you don't get that for free, so you have to put some effort into thinking about how do we structure our system well enough. There's a great book on evolutionary architecture, and I would definitely recommend reading it. The caveat I want to apply here that this is actually quite hard, because if you get the decisions ordered suboptimally, you find you end up doing lots of rework and refactoring. And I see this time and time again. I see teams saying, we're spending way too much time doing all this refactoring. How do we avoid that? And maybe they just need to switch the order in which they're making decisions. It's also worth pointing out here that when you strive for an architecture that can evolve easily, you're making some significant decisions. What do I mean by this? If you see people talking about ports and adapters or clean architecture, they'll often say you need to decouple your business code from your technology code and your infrastructure so you can change the infrastructure later. That's fine, but the significant decision you just made is to add that additional level of abstraction, which requires more complexity, more code. Now, you might argue that's always worth it anyway, and that's fair enough. I think I probably agree there. You look at something like a microservices architecture. A microservices architecture gives you lots of flexibility because now you can switch out individual services, you can version services independently, you can have different teams looking after different services. You just made a whole bunch of significant decisions there, often unknowingly, without understanding the trade-offs and the consequences. So we should definitely strive for architectures that can be changed easily, but we need to put some work into that. Nothing's free. So what I'm trying to do here is I'm trying to put some degree of upfront design in place to create a decent starting point. And I'm going to emphasize this is a starting point and we can change it. But I want any changes made in a justified manner. That's really all this is about. The other reason I like doing upfront design is that it's about discovering the unknown unknowns. So when I was a consultant building software solutions for and with our customers, one of the things I liked doing was creating a software architecture document from a template, because then that template would force me to go and ask a bunch of questions like, have I considered security adequately? What are my performance characteristics? What about scalability, and so on and so forth? And without that template guiding my decisions, I might have missed some stuff. So that starting point, I think, is super useful and it adds a lot of value. And that's really why I'm doing this. And this applies to all teams. So I like to think about architecture as being technical leadership, and every team needs technical leadership, irrespective of how big or small they are. So that's upfront design. That's a big part of the puzzle. I'm going to come back to completely incomprehensible software architecture diagrams because this is one of the things that hurts us the most, but it's probably the easiest to fix. One of the things I like doing is I ask audiences, who uses UML? Now, this is kind of hard to do via Zoom, but often the responses I get back are, well, we don't know UML. That's not something we use in our organization, or maybe I'm the only person on the team who does know UML. That's becoming more and more common. This varies a little bit depending on country and culture, but typically it's in the 1 out of 10 type ratio. I do have to say it's normally higher in the Netherlands. So in the Netherlands, for reasons I don't really understand yet, normally it's like 2 or maybe 3 out of 10. So maybe there's a bit more of an engineering type culture in the Netherlands and also Germany. I've heard some interesting excuses for teams not using UML. A team genuinely last year said this to me, and if I told you who this team was, you'd be absolutely horrified. It's a very big and very well-known company. So if you use UML in this company, you will be seen as old. This was followed up by you'll be seen as old-fashioned, which I thought was hilarious. I mean, I've never heard that about something like UML before. This is an interesting one. We don't want to use UML because we don't want to tell our developers what to do. And again, it seems that teams have coupled doing UML, which is a diagramming notation and a modeling notation, with upfront design and dictating design decisions. And of course, they're two separate things. The tooling does suck. I can't disagree with this. A lot of the UML tooling is horrible. The diagrams look very ugly, and that does not help its case. It's too detailed. Yeah, I think a lot of people get sucked into doing very low-level class diagrams and sequence diagrams, and they don't realize there's package diagrams and component diagrams and activity diagrams, and there's a lot more high-level stuff, but we never put any focus on that. This guy said UML is a very elaborate waste of time, which I thought was quite funny. He said this on his YouTube video. And then he had a little spiel about why this is the case. And then he basically presented his solution. And his solution was just use a whiteboard. Yay. Now, that kind of makes sense. And I'm a big fan of whiteboards and pieces of paper, especially when I'm doing upfront design. The problem with just use a whiteboard is, as I've already shown you, the diagrams don't make sense. We need to put some more structure and frameworks and guidance into the way we're using the whiteboard and the content we're producing that goes on that whiteboard. So just use a whiteboard is not a particularly great piece of advice, but that's what you hear most people say these days. And it's at this point people say, well, hang on, Simon, what's wrong with these diagrams, right? You've basically said these diagrams are horrible. You've not really explained why. One of the things we get our groups to do after they've done that first iteration of the design exercise and they've come up with horrible looking diagrams is they swap the diagrams again. And I asked the groups to answer these two questions based upon the diagrams they've just got to see. So question number one, does the solution you are looking at now satisfy the architectural drivers? So the requirements and the non-functional requirements in this case. And if you were the bank, the customer in this case, would you buy this solution? And we give people like 10 minutes to do that. And at the end of this 10-minute exercise, the groups come back to me and say, no, we can't answer those questions because there's not enough detail on the diagrams. And that's exactly what I'm trying to get to here. If you can't see and understand the solution being presented, you can't evaluate it, which means you can't reason about it, which means you can't make lots of decisions based upon that artifact. Coming back to things like UML and diagramming, it's not expected in Agile. Here we go again. People have this funny thing that if we're doing Agile, we can't use UML. Like these two things are somehow incompatible. Where does this come from? Again, it comes from a lot of the original literature around things like extreme programming. So would it be better if we used the case tool? A case is like an old-fashioned approach for a modeling tool to lay out the design. And then Ron Jeffries here says, no, it wouldn't. The design is more readily expressed, changed, and understood when done less formally with CRC, so I like CRC, or on the whiteboard, or a bar napkin. Come on, a bar napkin? We're telling people to use bar napkins, please. Another paragraph. You may well need some nicely formatted UML for your project, and then a whole bunch more words. But inside your co-located whole team, you most probably will not need them because the information you need will be communicated through the more effective medium of conversation. And you'll see a lot of Agilists and proponents of Agile saying the values in the conversation. We should have conversations around the whiteboard and not worry about these longer-lived artifacts like documentation and diagrams. So the values in the conversation, and this is a reason that a lot of people give me for not creating diagrams and for not using things like UML. Someone actually said this to me, I think in person a while back, and they said all of the diagrams you've shown during this presentation, they're all excellent as long as there is a conversation about their meaning and intent. It's the accompanying conversation that matters. So again, they're really kind of backing up the values in the conversation thing. And that's fine, but the values in the conversation only works if you can have the right conversations. And if you've got a diagram that makes no sense whatsoever, and you're having to ask, what's the red box versus the blue box? You can't get to the right conversation about, oh, I've seen you split this thing up into 4 microservices, not 3. Why is that? So these diagrams don't necessarily facilitate the best conversations. And that's the thing I want to fix here. Unfortunately, in order to get to that point, we have to talk about superficial upfront design. So many people think they're doing upfront design, but they're not. They're doing something subtly different instead. What programming language should we use is a great discussion to have when you're doing upfront design. And one of the things I see on many of the architecture diagrams showing my design exercises is you see a bunch of boxes with no technology choices. And often if you have a group of 2 people and there's a Java person and there's a .NET person, they'll see the solution through their eyes. So the .NET programmer will think, well, this is obviously a Java solution. The Java programmer thinks it's a Java solution and the .NET programmer thinks it's a .NET solution. And it turns out they've got very different interpretations of the same diagram just because of their experience and context. Same thing with microservices. I've seen a bunch of groups create a number of boxes with links between boxes. Half the group will think this is a microservices architecture. It's all completely distributed. And the other half of the group will think, no, I thought we were designing modules in a monolith. And because they've never had that explicit conversation, there's this clash of understanding that comes quite late in the game. We all think that cylinders mean databases. I've actually had people say that the cylinder is a standard shape in UML, and I'm pretty sure it isn't. And sometimes cylinders are not relational databases, they're something else instead, and that throws people. Why is the ORM, the Object Relational Mapping Framework, directly connected to the Angular front end? This is a bit specific, but bear with me for a second. So this is one of the architecture diagrams I showed you earlier. It's the layered architecture. So there's an Angular front end and there's a .NET back end. And if you look on the right-hand side at the top, there's a report viewer box, and it somehow has a link down to the data storage or ORM box in .NET. So I asked the group, I can see you've got an Angular front end somehow talking to or being talked to from .NET. How do you do that? Like, oh, good point. That's not possible, is it? And again, they hadn't spotted this on their diagram, and it just kind of told me they hadn't put much thought into this. Another one I came up with last year is the web UI getting data from S3. So the group drew an architecture diagram. It had a box labeled web application and a box labeled S3 and a line between them. So I said to them, is your web UI getting data from S3? And they said, yes. I said, okay, that's fine. What is your web UI? And then they said, it's an Angular app. I said, okay, so where is your Angular app running? Is it running in a web browser? And they said, yes. I said, well, how is your app in your web browser talking to S3? And they said, oh, there's a JavaScript API. I'm like, that's nice, but where are you putting your credentials, your API keys and sequence? And they're like, oh, that's not a good idea to have it publicly accessible, is it? No, it's not. Again, they hadn't thought through these issues. It was only when I pointed out to them, of course. And that's the thing. We're not often fully engaging our minds in the problem space. And therefore, we come up with these very simplified, superficial views of the world. And I see this a lot. Whenever I see one of these quite generic kind of logical architecture diagrams, just named boxes with links, it kind of tells me that the group's not really thought through the problem well enough. You may have seen this before. It's the typical S-curve of learning. Big design up front tended to take us right up to the plateau. So we do lots and lots of work, and our benefits would decrease as we did more and more work. There just wasn't much more value add there. If you don't do any upfront design, you kind of get stuck on that slow initial progress part because you don't really do enough thinking to discover anything interesting. So what I'm trying to do is I'm trying to get people up that curve into the accelerated learning part as quick as possible, and then stop when they feel they've got the most benefit. And that's something that doesn't need to take weeks and months. It can take hours and days, but we just need to get people's mindsets shifted slightly. And none of this happens for free. So there's a great book on software architecture by a friend of mine, George Fairbanks, and he says this: a good architecture rarely happens through architecture indifferent design. Architecture indifferent design is basically making decisions because that's the way we've always done stuff in the past. Because why not? Because of trend and hype and fashion. And I see this a lot, unfortunately, with things like microservices and serverless environments. Groups and teams jump on these types of approaches just because they're cool. It's the CV-driven design thing. And they don't really understand the trade-offs that they're making. And I want teams to kind of step back, pause, breathe, and just evaluate the decisions that they're making. Speaking of decisions, technology decisions. Often on iteration one of the diagrams, there's not much technical detail. And when I ask groups, why haven't you put much technical detail on the diagrams? They often say this: we don't have enough detail. We don't have enough information to make those decisions. To which my response is, well, I'm stood in the room. You could just ask me and I could give you all the information you want to. So that's a bit of a non-issue, to be honest. This is funny. We don't solutionize. Like, what on earth does that mean? We also don't solutionize this early. I had a group I visited last year, again, another very well-known company, and they said, our architects don't solutionize. I'm like, wait, what? Surely the point of architecture and design is to come up with a solution. I'm not even sure solutionize is a word, to be fair, but it seems like they didn't want their architects to come up with any form of solution, which I thought was a bit weird. Even better was this one: our architects are not allowed to do solutioneering. Like, that's even less of a word than the last one. But again, the whole point of architecture is to do solutioneering, if that is a word. We don't want to impose a solution on the development team. This is kind of interesting because one of the things a lot of teams want to get away from is this dictatorship approach to design and architecture, where you have a bunch of people working in isolation in a nice office somewhere, and they throw a solution to a development team who gets no say in what's going on. I don't think we should do that. But again, I think the whole purpose of putting some upfront design in place is to reduce the solution space. I think it's useful to put some guidelines and boundaries and constraints in place. Otherwise, it's a complete free-for-all. And again, both extremes are not very helpful here. Same sort of thing. We want to leave our developers to choose implementation details. I kind of agree and disagree with this. It's one of those things. In some organizations, in some countries, they don't like putting the design and architecture responsibilities on a single person, and they prefer to share out all of the roles amongst all of the teams. So you'll hear people say, you know, we're all software architects on this team. Right? We're all jointly responsible for everything. That can work, but it has its issues. And I've also seen organizations where they have let developers choose whatever they want to, and they've got into a mess for a whole bunch of different reasons. So again, you have to take this with a pinch of salt. The team should use the implementation strategy, same deal. We're a Java team, so it's obviously a Java solution. I see this a lot. Again, if you get a bunch of Java developers together and they create an architecture diagram, they never put any technology choices on it, but they assume it's a Java solution. That might be obvious to them. It's not obvious to me as an outsider. So you do have to watch out for that as well. One of the interesting things I noticed over the past couple of years is that during iteration 1, teams are very hesitant to put technology choices on their architecture diagrams for a whole bunch of reasons, like those I've just talked about. When the groups swap diagrams, one of the biggest feedback points is, I wish these diagrams had technology choices on them, because then the diagrams would be much easier to understand. So you get this interesting producer-consumer conflict with software architecture diagrams. The people creating them don't want tech choices, the people reading them do. So I guess we need to wrap up this talk. And I want to wrap up this talk by answering this specific question. So since I'm advocating some degree of upfront design, how much should that be? And also, what sort of activities, techniques, and practices do I think make up a good lightweight upfront design process? The way I like to think about this is, let's step back for a second. Imagine you're at the whiteboard with some colleagues, assuming you're allowed to go back in the offices and stuff, and you're out there drawing some diagrams. You want to be able to answer 2 key questions about the design you are creating. And of course, this could be a greenfield project, or it could be that you're doing some design at the start of a sprint, for example. And the 2 questions you want to really ask yourself is, do the diagrams reflect what we think we're going to build? And question number 2, are we confident that this solution, this design, is actually going to be implementable? Is it going to work? With the diagrams I've shown you, you just can't answer those questions. So that's why I'm so focused on getting these diagrams up to a much, much better standard. I just want to reiterate this, kind of said this earlier, we're not trying to make every decision. We're trying to put a starting point in place, so we don't need to make every decision. And some decisions, it turns out, are much more important than others. How do we know which decisions to make? Grady Booch has a great saying that's been always quoted around software architecture. And he says this: architecture represents the significant decisions, where significance is measured by cost of change. And I think it's a really good, simple way to look at the types of decisions we want to make. If those decisions are hard to change later, we should probably try and get them right, or at least think about them. The types of decisions you want to be thinking about, the architectural type decisions, include choice of technologies. So what types of programming languages are you planning to use? What frameworks are you going to embed into your code base, the things that are hard to change later? And what deployment platforms might you be using in the future? Are you going AWS or Azure? That's going to sway you one way or the other. And also things around modularity. Is this a monolith? Are we cramming all of our features into a single deployable unit? Or are we splitting our system up into a bunch of distributed microservices? Or is there some hybrid in between? Again, we don't have to do extremes all the time. We could put the majority of our business features in a monolith, with the more volatile things sitting in their own services, maybe owned by different teams. The problem with significant decisions is that there's no easy way to define, well, all of the stuff above the line is significant and all of the stuff below it is not significant. So it's more of a spectrum of different levels of decisions. So the sorts of things I've outlined are definitely significant. Stuff like, do we use white spaces versus tabs? I don't care, right? Just choose one, chuck it through a linter. It doesn't really matter. I'm not interested in deciding that stuff up front. Martin Fowler, a number of years ago, actually said this on his Blicky: I think there is a role for a broad starting point architecture. Such things as stating early on how you're going to do layering, how you're going to interact with a database, and what approach you're going to use to handle things like web servers. And I completely agree. And that's the significant decision things coming back into play again. So just be wary of, just use whiteboard and the values in the conversation. We need to have better diagrams and have better conversations as a result. Tooling doesn't help. So if you can't draw good diagrams, if you don't know what sort of decisions you need to make, just using a nice tool is not going to help you. So here are a bunch of example architecture diagrams I stole off the web. They all have the same problems: boxes and no lines, unlabeled arrows, color coding. I have no idea what it means. We've got a bunch of acronyms. We've got different shapes, different sizes. These diagrams have the same issues. They just look slightly nicer in most cases. They don't help you answer these two questions again. In terms of diagramming, I think we need a ubiquitous language. And I think we need to figure out how to communicate our design ideas better as a team. And just a bunch of random scribbles on a whiteboard that you can't take to another team because they don't understand, and that's not effective. So something I came up with is called the C4 model. And the C4 model is really two things. On the one hand, it's a set of hierarchical abstractions that you use to describe and talk about and think about software systems and architecture. And the other side of it is a set of hierarchical diagrams. So for me, when I'm thinking about a software system, for me, that software system is made up of one or more containers, not Docker. Apologies, I came up with the word way before Docker existed. But basically by container, I mean application or data store. So client-side web apps, server-side web apps, database schemas, folders on a file share, and so on. When you look inside these things, I'm calling containers, applications and data stores. They're made up of components. A component is basically just a grouping of stuff, hopefully a nice, well-defined interface. And when you look inside components, they're basically made up of code and code level elements. So if you're building a Java component, you're using Java interfaces, classes, and enums. In C#, it's the same. In F#, it's going to be functions. In JavaScript, it's going to be functions and objects. So it's your code level constructs in the languages that you're using. So it's a nice, simple hierarchy of things. Once you have that hierarchy, you can then draw some diagrams at each level. So there's a system context diagram that basically shows you the system you're building and how it fits into the world around it. You then zoom into the system to show the containers. So this is where you show your front end Angular app talking to your backend Ruby on Rails app talking to your MySQL database. You then optionally zoom into a single container to show components, and then you definitely optionally zoom into a component to show code. There's a lot more information and example diagrams on c4model.com, but the simplest way to think about this is maps. So it's diagrams as maps. So you start out with a nice high-level view of something, and then you progressively zoom in. You pinch the zoom in to get more and more detail, and eventually you drop down something like Street View. And Street View is like code. It's like the one-to-one mapping with reality. And those different levels of diagrams allow you to tell different stories to different audiences. So the high-level diagrams work best for more non-technical people, and the low-level diagrams definitely work better for developers. Most teams only tend to do the top two levels of the C4 model, but there's a little bit of benefit in level 3 if you want to go that far. One thing I want to say about the C4 model very briefly is that it's notation agnostic, it's notation independent. So you can use UML if you want to. I don't see people doing this, but you can if you want to. If you go into the c4model.com website, there's a notation checklist. So the next time you draw an architecture diagram, pull this thing up, answer a bunch of questions, and it'll hopefully give you some tips on how you can improve your diagrams. And I like using these diagrams as a visual checklist for my design decisions. So in order to draw a system context diagram, we need to ask these questions. What's the scope of the thing we're building? Who's using, what are they doing, and what system integrations do we need to support? And this is an example of a system context diagram for the financial risk system. And it's got a couple of user types and the external systems in the organization that we're also going to hook into. And it's a great starting point. It's not super detailed, but it's a nice high level overview. We then pinch to zoom into the red box, the financial risk system in the center, and we draw a container diagram. And in order to draw the container diagram, we need to ask, what are the major technology building blocks? What are the responsibilities, and how do they talk to one another? And if you do it well, you might get a nice looking diagram like this, which has a couple of different web apps. We've got some server web apps, some client-side web apps. We've got a risk cruncher command line thing. And again, it's just a nice diagram that tells you the runtime things, the applications and data stores that are going to be built to implement this solution. And these diagrams should now help to spark good and meaningful questions. Not stuff like, what does the arrow mean? Why is this box red? Why is this box blue? We want to be asking much, much better questions. Stuff like this. Oh, I can see you've got two Java apps. How are they talking to one another? Why are you using MongoDB when that's not our standard? So these are the questions I want us to be asking when we see these diagrams. I want us to be asking design questions, because then we get better discussions. And now the value's in the conversation. Couple that with some architecture decision records to record all the significant decisions you are making, and you get a really nice lightweight pack of documentation. So these diagrams, they should provide meaningful feedback. I've got about 2 minutes left, and then we'll open up some questions if that's allowed. So one of the things I see people doing is they're trying to design a microservices or a serverless type architecture, and they say to me, Simon, we find that it's hard to draw an architecture diagram because our diagram is getting complicated. Exactly. So is that what we're going to build it? Is it going to work? And maybe you have a complicated diagram because you have a complicated solution. So again, use these diagrams as your feedback mechanism. Scott Ambler, just to wrap up, he says you should base your architecture on requirements, travel light, improve your architecture with concrete experiments. And this is really the missing piece of the puzzle. For me, we need to figure out what the highest priority risks are, identify and mitigate them. And I like to take a very collaborative approach to this, because risk identification tends to be very subjective. If you have the one architect identifying the risks for a particular solution, you'll get the risks through their eyes. So I like a nice collaborative approach to risk identification. I have a technique you can find online called risk storming. And again, it's a nice way to get lots of people's different inputs. It's exactly the same concept as something like planning poker is for estimation. You identify the risks, you focus on the high priority risks, and then you write some code. And writing code has a whole bunch of different names, proof of concepts and prototypes and spikes and tracers. But basically, we're figuring out where our highest risks are, and we're writing some code to prove a hypothesis. So is this thing really going to work? And that's the missing piece of the puzzle, essentially. So in terms of how much upfront design should we do, you might hear people saying stuff like this: I'm good with maybe 1 day for a 1 year project. That might make sense, but I like to think about this in a slightly different way. So for me, any upfront design we do is an iterative and incremental process, and we should stop when we understand what the significant architectural drivers are. In other words, we understand the high level requirements, not everything, but the high level requirements. We understand the important non-functional requirements, the quality attributes, so security and scaling and performance if they're important, and we understand the constraints in which we are working. If you understand the context and the scope of what you're building, so if you can draw a system context diagram, you're in a good place. You understand your significant design decisions, especially around technology and modularity, and that's where drawing a container diagram fits in quite nicely here. You have a way to share this vision with other people. Again, that's where the good diagrams come into play. You're confident that your design satisfies the drivers. So is it going to work? Yeah, I think it will, because we can see that from the diagrams. and you've identified the risks and you're comfortable with the risk profile you have. This is why one of the reasons I like the rational unified process, because it front loads the risky stuff to the start of the life cycle. So that's really my kind of, in a nutshell, guidance for doing just enough upfront design. And you have a whole bunch of different techniques and practices that you can use to get there. And that's the stuff that needs to be in our toolbox. So we're putting a starting point in place, we're setting a direction, but we can still do evolutionary design to change direction when we need to. And we change direction when we get feedback. Architectural katas and design exercise are a great way to practice your design and communication skills. So if you're not doing that sort of thing, that's very easy to do internally. You don't need me to do that. And my closing advice is adopt an agile mindset. So when we think about adopting techniques and practices, ask yourself, is it working? How can we improve it? And basically you need to figure out and discover what works for you. So thanks very much for listening. I have some software architecture books. If you go to this URL, which I will send to the organization team and they can send out to you, or someone can paste it in the chat right now if they want to, that will get you these books for free. So no need to pay for them. So with that, I'll say thank you very much. And I will pass it back to the organizers.